Hello and welcome. I'm George Crump, Chief Steward at Storage Switzerland. Today's webinar is on overcoming the server virtualization storage I/O blender. That's a big title, but this is a big subject and it's one that's important. So we're going to go through this. It'll only take about 5 minutes to give you some overviews, and then we'll point to some resources on the Storage Switzerland website. First, some background on Storage Switzerland. We're an analyst firm focused on the storage, virtualization, and cloud computing marketplaces. So what are some of the goals that most people have when it comes to virtualization? Well, obviously the first thing you want to be able to do is reduce the physical server count. By and large, server virtualization has been wildly successful at that. Then you wanted to increase CPU utilization. Well, you know, there's what typically happened is customers went out and bought really large servers and put old applications on it, so I don't know if we necessarily achieve that every time. And then third, we wanted to reduce server provisioning times. And we've done that to an extent. And then finally, we wanted to increase agility. And that is being more flexible and responsive to the needs of the business. If you kind of put this into a curve, most virtualization projects that we're associated with kind of follow these steps. First, there's a pilot phase. You test it, make sure it works. Surprisingly, I think to most people, it works really, really well. Then you start to move in what we call simple production. Somewhere in between here, you think about getting new servers and buying the actual software and trying to figure out what applications to put into this new virtualized environment. Then the goal is to move to full production and then eventually to what we would call a virtualized data center, or what a lot of people call a cloud-based data center. The problem is that most virtualization projects are really stuck at simple production. What happens is the project is wildly successful, but there's some roadblocks to getting all the way through to complete virtualization and getting to that completely virtualized data center. We're going to focus on one of the big ones today, and that happens to be storage. Storage really creates negative agility in the virtualization project, which, of course, if you remember, one of the plans was to increase agility. And storage really is the bottleneck. SAN, what we find is most of the time the capabilities of the SAN are not being leveraged at all. There's capabilities like NPIV, and now there's some vendors like Brocade, as an example, have the ability to do QoS or quality of service at the NIC or HBA level. That's really important when it comes to putting this and really applying this to more mission-critical applications. But of course, you need shared storage for vMotion and Site Recovery Manager and all the other features that everybody gets excited about. So how do we kind of get those two things working together? Probably the most important thing is storage has to really understand the abstraction layer and what the needs of the individual virtual machine are. Too often, common systems today just treat it as the needs of the ESX server, and then the hypervisor has the responsibility to try to figure out all the different needs and wants of the individual virtual machines. So before the I/O blender, life was good, right? We had a single server. Each one had its own network and its own storage I/O. It was really easy to understand where the performance problems are. If you had a storage performance problem, you either got faster storage, put a solid-state disk in, did something to increase your overall performance. It was a one-to-one relationship. From this perspective, it was relatively easy to understand and figure out. Of course, we had other challenges with it, and then we had heavily underutilized CPUs, heavily underutilized storage, and heavily underutilized network traffic. So to kind of, as is always the case in IT, to fix one problem, you break 4 others. So that's what happens as we start to move into server virtualization. What has happened here with server virtualization, we've created what I call the virtual machine I/O blender. So now you can see the picture changes. We still have that one physical host, but we may be running 4 different workloads on it. And so this abstraction layer creates these multiple virtual machines, but we really still have a single hypervisor trying to manage the whole thing, and a single HBA and a single NIC. Now, in fairness, there's generally 2, maybe 4 HBAs and 2, maybe 4 NICs, but the hypervisor really has to manage all this different traffic. So that really causes a problem. So as you start to look at this, diagnosing what application or what workload virtual machine needs what amount of traffic, and becomes a real problem here. And so the first step in solving this was to implement NPIV. And what NPIV allowed me to do is create these virtual HBAs. And with these virtual HBAs, I could begin to identify what traffic is coming from what workload. So I could at least use capabilities like, for example, Brocade's Top Talkers to at least list and see what worldwide names are the most active on the storage network, and I could at least make some moves as far as moving them to less active servers or maybe unvirtualizing them or something, but I could do something to now identify what was going on. Of course, with NPIV, which is prevalent now, we still only have one hypervisor, and we really have a limited ability to prioritize I/O traffic. So we needed something else. So we think the next logical step, and we're using Brocade as the example here, is to build QoS functionality into the environment. So what we can do is use specific HBAs that leverage NPIV to identify the virtual machines, and then communicating that a priority that they need to the switch. And so what that allows us is to say the black line there that's on that first virtual machine on the left, give him sort of the high priority traffic, and then maybe the second one with the orange line, give him sort of medium traffic, medium priority traffic, and then the last two give them sort of low priority traffic. And the way we get there today is we apply extra buffer credits to the high and medium HBAs, and that allows us to give some level of performance guarantee to the owners of these more mission critical applications. So this is really a critical step in taking mission critical applications and increasing machine density and really moving the virtualization project further along the line. So some key takeaways here is, number one, the switches and HBAs need to be compatible with each other to support virtual machine prioritization. So what you want to look for is vendors that can provide basically a turnkey HBA and switch bundle. We clearly expect some standardization there, especially around FCOE. There's some things built into the Enhanced Ethernet standard that should allow for additional QoS type of functionality. Of course, we'll have to see how that evolves. What we know today is that the turnkey HBA switch method works really well, and it's available now. The storage I/O, the other key takeaway is storage I/O prioritization is critical for increasing virtual machine density. Mission critical applications and application owners are going to demand service level agreements, or SLAs, from the virtualized environment. They're not going to be real keen on letting their mission critical application be virtualized without having some sort of consistent performance on their application. So that consistent level of performance is going to be very critical, and that's where this QoS capability really comes in. The other end of the equation would be to over-allocate bandwidth and just push a bunch of 10 gig servers in there and hope the hypervisor can sort it out. Number one, that's just way too expensive to do, and really what you want to do is apply the right level of bandwidth at the right time to the right workload, and then QoS is really the trigger that allows you to do that. And so this is going to be the best way to implement this next generation networks, of whether it be 10 gig FCOE or 16 gig fiber channel or even 8 gig fiber channel. Being able to carve that bandwidth up and getting it to the right workload at the right time is really going to accelerate adoption of these things, as well as make virtual infrastructures much more dense, and then really turn the crank once again on the ROI payoff on that technology. So that's it. Try to keep it quick. If you have any questions, please email me directly, gcrump@storage-switzerland.com.